In question 7.1, it says that an investment earns an interest rate of 12% per annum compounded every 6 months. Calculate the effective interest rate of this investment. So we are told that the interest rate is equal to 12% compounded every 6 months, meaning half yearly, right? So it means half yearly, which is 1 over 2. So it's half yearly, right? So we are asked to find the effective interest rate. So it's going to be 1 plus I effective equals to 1 plus I norm over m to the power m. So we're going to transpose the 1 to the other side. We have I effective equals to 1 plus I norm over m to the power m minus 1. So we substitute. So it's 1 plus the 12% is going to be 0.12 divided by our half yearly, which is 2 to the power 2 minus 1. So our I effective is going to be equals to 0.1236. Then we multiply by 100. Our I effective is equal to 12.36. So this is our effective interest rate. 7.2, a company bought an equipment that depreciates at 7% on a reducing balance. How many years will it take for this equipment to be worth half its original price? So we are told that this equipment depreciates at 7%, right? And another thing that we need to note is that they say that the A is going to be half its previous price, right? So we're going to use our compound interest rate. Why? Because this is a reducing balance. Reducing balance is the compound formula, the decay compound formula. So we're going to say A is equals to P into I minus. So the formula is going to be A is equals to P into 1 minus I to the power n. And instead of writing A, we're going to write half P. So it's going to be half P equals to P into 1 minus I to the power of n. And then we divide out the P. We have 1 over 2 is equals to 1 minus I to the power of n. And our I is 7%, right? So it's going to be half is equals to 1 minus 0.07 to the power of n. So we want to find n. So we're going to use log. So it's going to be n is equals to log base 1 minus 0.07 and multiply with 1 over 2. Then our n value should be 9.55 years. So now 7.3, we are told that Kenneth invested 250,000 into an account that pays an interest rate of 9.5% compounded quarterly. 12 years after making the initial investment, Kenneth bought a house that cost 2,920,000. He used all that money he accumulated in his investment as a deposit for this house, and the bank granted him a loan for the remaining balance, right? The bank charged interest of the loan to 10.3% per annum compounded monthly. So the loan was for a period of 20 years, and first monthly installments were made 1 month after granting of the loan. So 7.3.1, we are asked to find the value of Kenneth's investment after 12 years. So what we know is that Kenneth made an investment of 250,000 rand, and the interest rate that was given was 9.5% per annum compounded quarterly, right? Cool. So now we're going to use the compound formula to find the money that he accumulated in 12 years time. So it's A is equal to P into 1 plus I to the power of N. His investment was 250,000 rand, and into 1 plus, so the interest rate is going to be 9.5%, so we're going to write it as 0.095 divided by 4 since it's quarterly, and to the power of 4 multiplied by 12 years. So the money that he accumulated for 12 years is 771,343.67. So this is the money that he accumulated in 4 years time. So now 7.3.2, determine the value of the loan that Kenneth obtained. So for us to find this, we need to first write down the money that he accumulated, which is 771,343.67. So this is the money that he accumulated in 4 years, right? The loan, for us to find the loan, we first have to find the value of the house. So the cost of the house is actually 2,920,000 rand. Bagumsindo man, hey. So to find the value of the loan, we first need to identify the cost of the house, which is equals to 2,920,000 rand, right? So the loan will be equals to the cost of the house minus the investment that he accumulated. So it's going to be 2,920,000 rand minus the 771,343.67. So the loan that he got from the bank is going to be 2,148,656.334. So this is the loan that he'll get from the bank. So 7.3.3, calculate the monthly installments, or the monthly repayments rather, of the loan. So since we know that we're talking of the loan, right, means that for us to find the monthly payments, we need to use the present value annuity, which is equals to x into 1 minus into 1 plus I to the power of minus n divided by I, right? Our PV is the loan, which is going to be 2,148,656.334 equals to, we want to find the monthly repayment, so it's 1 minus into 1 plus so remember that the loan was for 10.3% compounded monthly, so it's going to be 0.103 over 12 to the power of minus 12 times 20 years. The loan was given for a period of 20 years. Divide by 0.103 over 12. Then we're going to cross multiply. So we will have 2,148,656.334 multiplied by 0.103 over 12 equals to x into 1 minus 1 plus 0.103 over 12 to the power of minus 12 times 20, right? And we're going to divide by this expression of 1 minus into 1 plus 0.103 over 12 to the power of minus 12 times 20, and also divide it here, so it's 1 minus into 1 plus 0.103 over 12 to the power of minus 12 times 20. So our x is going to be equal to 2,148,656.334 multiplied by 0.103 over 12 divide by 1 minus into 1 plus 0.103 over 12 to the power of minus 12 times 20. So your x value, which is your installments, would be 21,163.869. so these are the installments that is going to make. So 7.3.4, Kenneth paid off the loan at the end of 20 years. How much interest did he pay on the loan? So remember that the monthly installments of the loan was 21,163.869. So let's first find how much will he pay for the entire 20 years. So it's going to be x multiplied by n, which is equals to the 21,163.869 multiplied by the 20 years multiplied by 12, because it's going to pay for monthly. So then you're going to get 5079,328.568. So this is the amount that is going to be paying. So we want to find the interest that the bank made. So you're going to say 5079,328.568 minus the initial value of the loan. So it's 2148,656.334. So the interest that was made was 2930672.234. So this is the interest made.